Welcome to our video on parallelizing matrix multiplication using SIMD instruction. If you're working with large datasets or performing complex computations, you know how important it is to optimize your code for performance. One way to do this is by leveraging the power of parallel processing, and that's exactly what we'll be discussing today. In this video, we'll explore how to use SIMD or single instruction, multiple data, instructions to speed up matrix multiplication operations on a 4x4 row major matrix. By the end of this video, you'll have a solid understanding of how to apply SIMD principles to your own code and unlock significant performance gains. To start with, let's break down what we mean by SIMD instruction. Essentially, SIMD allows us to perform the same operation on multiple data elements simultaneously using a single instruction. This is particularly useful when working with large datasets or performing operations that involve repeating patterns. Now, let's dive into matrix multiplication and how we can apply SIMD principles to this operation. Matrix multiplication involves taking two matrices, A, B, and producing a new matrix C, where each element is the sum of the products of corresponding elements from rows in A and columns in B. For a 4x4 row major matrix, we can represent this operation as follows. Imagine you have 4 rows in matrix A, each with 4 elements. For each row in a, you'll multiply corresponding elements with the 4 columns in matrix B, summing up these products to produce an element in the resulting matrix C. Here's where SIMD comes into play. By using SIMD instructions, we can perform multiple multiplications simultaneously, reducing the number of operations required and increasing overall performance. Let's take a step back and consider how this works at a high level. Imagine you have 4 elements from a row in matrix A, which you'll multiply with corresponding elements from a column in matrix B. Using SIMD instructions, we can perform these multiplications simultaneously, producing 4 partial results that will be summed up to produce an element in the resulting matrix C. We can take this concept further by considering the fact that modern CPUs often have multiple execution units or pipelines. By dividing our data into smaller chunks and processing them in parallel using these execution units, we can significantly speed up our computation. Now imagine applying this principle to a 4x4 row major matrix. We can divide the rows of matrix A into 4 separate segments, each containing 1 element from each row. Similarly, we can divide the columns of matrix B into 4 separate segments, each containing 1 element from each column. By using SIMD instructions, we can multiply corresponding elements from these segments simultaneously, producing partial results that will be summed up to produce elements in the resulting matrix C. This process can be repeated for all rows and columns in matrices A and B, respectively. To summarize, here are the key points we've covered so far. SIMD instructions allow us to perform multiple operations simultaneously using a single instruction. We can apply SIMD principles to matrix multiplication by dividing our data into smaller chunks and processing them in parallel. By using SIMD instructions, we can reduce the number of operations required for matrix multiplication and increase overall performance. That's it for today's video on parallelizing matrix multiplication using SIMD instruction. I hope you now have a solid understanding of how to apply SIMD principles to your own code and unlock significant performance gains. If you have any questions or comments, please leave them in the section below. Don't forget to like this video and subscribe to our channel for more content on optimizing your code for performance. In our next video, we'll explore another technique for parallelizing computations using multi-threading. Stay tuned